on our last section of Unit 5, Exponents, and now we're dealing with something called scientific notation, which probably is something that you have heard of before, seen before, may or may not understand it really well, but we're going to try and improve that today. So scientific notation, one of the reasons that it is used is because when you're dealing with things that are scientific, I often think of anything out in space. You're dealing with distances that are really, really, really large, or you're dealing with things that are really, really, really small, like in medicine. Usually they're talking about things that are in parts per billion, which means you're talking about something that's really microscopic and tiny. So in order to do that, they came up with scientific notation, which makes those numbers a lot more manageable. So let's say your parents come to you and say, hey child, if you start with a penny, every day I'm going to double your money. And we'll see how much you have at the end of a couple of months. So I think, cool, Mom, Dad, I'll do that. So you start with a penny, and the next day they give you 2. The day after that, they double it and give you 4. The day after that, they give you 8. The day after that, they give you 16. The day after that, they give you what? They give you 32. 32 cents. Day after that, they give you 64 cents. Day after that, they give you $1.28, right? And they continue this pattern on all the way. So this is an 8x8 grid. So let's say they do it for 64 days. Okay? So right here would be the 64th day. And I say to you, well, tell me how good a deal that is. How much money would you make at the end of those 64 days? So you started with a penny. That's your beginning amount, right? On 0 days. They haven't given you anything yet. That's what you started with. On the first day, they gave you 2 cents. On the second day, they gave you 4. On the third day, they gave you 8. On the fourth day, they gave you 16, and so on, and so on, and so on. Correct? So what really happened was you have, this is actually 2 to the first that they gave you. 2 to the second equals 4, doesn't it? 2 to the third power is 8. 2 to the fourth power, they're doubling your money. So every day past the first day, they're doubling your money. So on the fourth day, they doubled your money 4 times. On the fifth day, they doubled your money 5 times. Makes sense? So now if I say to you, okay, tell me how much money you're going to have after 64 days. Well, you could go through and keep doubling these, but there's a little bit easier way to do that. So you started with $1, and they're doubling it 64 times. So this is a good time to use your calculator. So let's see what that gives us. So we have 2 to the 64th power. Holy moly, look at that. And you get 1.8, it's rounded off to cents to make our lives a little bit easier, 1.84-ish times, but you're thinking, wait a minute, I'm only getting $1.84? That doesn't make any sense, because over here I already had $2 2 cents, 4 cents, 8 cents, so I can't be getting 1.8 cents. But look at that little number up here in the screen. So what that is times the scientific notation. It means times 10 to the 19th. Well, the problem is your calculator only has 10 spaces here, doesn't it? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's only got 10 spaces. It needs 19, which really means that you're going to have 1, and then you're going to move this decimal out 19 spaces. Okay? So you would have 1, 8, 4, and you go out 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 spaces. Okay? And your decimal would now be way over here with all of those filled in with zeros. So make this offer to your parents. See how many of them take you up on it. Good luck to you getting paid out on that. So that is, boy, lots of pennies, yes? Let's see, what are we at? We're at this would be thousands, millions, billions, trillions, quadrillions, quintillions, 18 quintillion, 400 quadrillion pennies divided by 100. So it would be $18 quadrillion. So Good luck to you on your parents paying you that. I don't think that that's going to happen. But it's a really large number. And writing all those zeros out is really cumbersome. We don't want to have to do that. So when you have scientific notation, it's always your number multiplied by a base of 10 to some power. If that number is positive, that power is positive, you're talking about a really large number. If that number is negative, you're talking about a really tiny number. Okay? So for scientific notation, it's always the amount here, the first amount, and it's always between 0, or excuse me, wow, sorry about that, between 1 and 10. Okay? Cannot be, has to be actually 1 and less than 10. It can be 1, but it can be 9.999, but not 10. So if we were to write that as a inequality, it could be greater than or equal to 1 and less than 10. What happens then is we only ever have one number to the left of the decimal. Okay? So you have one digit to the left of the decimal, and that can't be a 0 because it has to be between 1 and 10. Okay? And then if the exponent is positive, we're talking about a really large number. If the exponent is negative, we're talking about a really small number. Okay? So let's do some examples of that. Will help you. Sorry for all my erasing today. Okay. So let's say we had 3.65 times 10 to the 5th. So that means I'm going to start at my 3.65, and if it's positive, that decimal point is going to move to the right, because think about what a number line is. Your number line, the positive is always to the right, and you're going to move to the right 5 spaces. So 1, 2, 3, 4, 5. And your decimal point is now over here, so you actually have 365,000. Anytime you're not sure, take that number. Anytime you have a 10 to any power, this tells you how many zeros are there, okay, to any positive power. So that would be a 1 with 1, 2, 3, 4, 5 zeros, which is 100,000. So that makes sense because 3 times 100,000 would be 300,000, and 0.65 of 100,000 would be 65,000. Okay, what if we have something that is, let's do the reverse of that. What if we have 2.63 times 10 to the negative 4? Okay, so we're going to start the same way. But now that decimal is going to move to the left 4 spaces. So I'm going to go 1, 2, 3, 4, because that's going to give us a really tiny number. So now you end up with 0.000263. So you have 5 spaces to the right of the decimal in this case. Here you have 4 spaces to the left because it's getting smaller. Okay, so now let's go from standard form and write our numbers in scientific notation. The first thing you have to do is figure out where your number would be between 1, something that's at least 1 but less than 10. So in that case, I would have to move my decimal right here. So it'd be 3.51, and then I just have to figure out how many decimal places I would have to go to get back to where it started. So I would have to go to the left, which means it's negative. Anytime it's under 1, it's going to be a small number. It's going to have a negative exponent. 1, 2, 3. So 3.51 times 10 to the negative third. So let's check. 3 is at least 1, but less than 10, 3.51. And it's a really small number, so my exponent is going to be negative. Okay, let's do the same thing with 6.71. So 6.71 would be in between 1 and 10. 67.1 is not. 671 certainly is not. So I'm going to have 6.71, and then I just need to count those spaces. So I have 1, 2, 3, 4, 5, 6. So times 10 to the 6th. And that is a large number, so I know that my exponent is going to be positive. Good. Okay, so you've already learned some properties for exponents, which help you kind of simplify larger exponential expressions, and you're still going to utilize those when using scientific notation. Okay, so remember the thing that your things that we learned from the first page, and it's going to apply to the second page. So let's try here. So first we've got the product property, right? We're multiplying one exponential function to another. So what you're going to do is you're going to multiply the coefficients first, okay? And this is a good time to use your calculator. So you can multiply this by hand too. 4.9 times 2.8, and you get 13.72. I really apologize for my miswriting today, you guys. 13.72 times 10. Now when you have the same base and they're being multiplied, we know from our product rule that we can just add the exponents. So I'm going to add negative 3 and 2, which gives me negative 1. So now let's check and make sure that we've got everything where it needs to be. So is my number here between 1 and 10? Well, it's not. 13 is more than that. So that decimal actually needs to get dragged back right to here. So I need to change that number to 1.372 times 10, and then I've got to adjust this. So those kind of have to balance each other out. If I have to move that decimal to the left one, then this has to increase by 1, because those will offset each other, cancel each other out, and keep the value of my scientific notation the same. So negative 1 plus 1 is just 10 to the 0, which is okay. So let's check that just to be sure. So 10 to the negative 1 is 0.1, right? It's 1 over 10. So if we multiply 1 over 10 times 13.72, we should get 1.372, which is exactly what we have here. We know that anything to the 0 power is 1, so 1.372 times 1 is just 1.372. So now we've double checked it and we're good to go. Okay, let's do the second example. So let's figure out our coefficients first. You're going to multiply your coefficients. So 3.76 times 8, wow, 3.76 times 8 equals 30.08 times 10. And now using our product property, I'm just going to add those two exponents and get times 10 to the 4th. Again, make sure that your number is between 1 and 10. This one is not. So to make it between 1 and 10, I need to move that decimal back one spot to make it 3.008. And to offset moving it to the left, which decreases it, I need to increase this exponent by the same amount. So I actually get times 10 to the 5th. And again, you can check that. If you have 30.08, let's check what we originally had here. 30.08 times 10 to the 4th is a 1 and 1, 2, 3, 4 zeros. And I get 300,800. And now let's check the same thing. So here we have 3.008 times 10 to the 5th is just 1 and 5 zeros, 1, 2, 3, 4, 5. And I get exactly the same answer. So I'm good to go. Okay, power property. Power property is actually a little bit easier. So what does our power property say? It says that when we raise a power to a power, we multiply those exponents. Okay, so this is actually a little bit easier than product property. So you're just going to take your number that's out in front, 3.7. It's between 1 and 10, so we're not going to have to adjust that at all. times 10, and now I just multiply. Negative 6 times 2 would be negative 12. So I want you to ask yourself, do you think that's a really large number or a really small number? That exponent is negative, so it's going to be a really small number because that decimal is going to move to the left 12 places, so it's going to be 0.00037, really tiny number. Okay, let's do the power property one more time. So bring our number down, 7.8 times 10. When I raise a power to a power, I can just multiply the exponents, so I get 10 to the 15th. This is a really large number because that exponent is positive and it means a 1 with 15 zeros behind it. Okay, good. Okay, and the last property that we worked with in section 5.2, I believe, was the quotient property. Actually, I think that was section 1, wasn't it? So we're going to do the same thing, and you're going to treat them as two separate fractions, just like we did with the others. Okay, so 12 divided by 4 is 3. And then you just need to ask yourself, for this base of 10, do you have more more on top or on the bottom? And I have 3 on the top and 2 on the bottom. So 3 minus 5 is negative 2. My number in the front is between 1 and 10, so I'm okay. And that's my answer. Now you can also check this out to make sure that you're correct on that. So 12 times 10 to the third would be 1,000. Would be 12,000 divided by 4 times 10 to the 5th, 1, 2, 3, 4, 5, would be 400,000. Right? So I should be getting a fraction here, something small under 1, because 12 divided by 400 is definitely less than 1. So let's go 12,000 divided by 400,000, and I get 0.03. If I were to rewrite this as a expanded number, I would start with my 3, my decimal is here, and bring it back 1, 2 places, and I would get 0.03. Okay, good. Let's do the last one. So let's do 2.25 divided by 2. Which gives us 1.125. So already I'm in good shape. I'm still above 1 but less than 10, so I'm fine. Times 10. And you can move this to the top, which is one of my hints I gave you, or you can just do 2 minus negative 6. When I have a negative negative, that adds, and I end up with 10 to the 8th. So let's check that out again just to be sure. So 2.25 times 10 to the second means that that decimal bumps out 2 spaces to the right. So that's 225. And 2 times 10 to the negative 6 means I would start here and go back 6 places. So that would be 1, 2, 3, 4, 5, 6. Which means I'm trying to take little tiny parts and see how many times that can go into a big number. So that's going to be quite a few. So 225 divided by 0.12345 zeros and a 2, and I get, let's see, what do we have? Thousands, millions, 112,500,000. And if I check that with this, that should be 1.125, which means I should have 8 digits to the right of that. And I have 1, 2, 3, 4, 5, 6, 7, 8. So I'm good to go. So that's the end of your scientific notation. We'll definitely do practice in class. And talk to you then. Thanks.